book asks us to figure out a way to use different different tools, probability tools, to come up with a 75% chance of something happening. And the first thing they ask for us to use a coin. So now clearly if I flip a coin, I've got a 50-50 chance of it being one thing or another. How can I turn that into a 75% chance of something happening? Any ideas?
Getting heads 3 times by rolling. Getting heads 3 times by flipping it 4 times.
Flipping it 4 times, getting heads 3 times? I'd have to look at that. That's maybe a little more complex than the answer needs to be. It could be correct. Yeah? Yeah, do you have a thought? You're going to say that? I'm going to say let's try just flipping it twice. Let's see what flipping it twice does for us. So if I make a table where this is maybe flip 1, this is flip 2. So this would be heads and tails, and this is heads and tails. So heads and heads, heads and tails. This would be tails and heads, and this would be tails and tails. So my event space has 4 things within it. Is there a way that I could say, here's how I could get a 75% chance of something happening? Yeah.
So you just say that like one of them, if you get one of them, it'd be a failure, but then the other 3 would be a 75%.
Okay, yeah. So what's a logical, yeah, if one of them's a failure, the other 3 would be your 75%, but what's a logical way of saying that?
Like say just like tails would be your 1 out.
Okay. So how about in 2 rolls not getting tails tails? Yeah? Or in 2 flips. Not getting tails tails. Yeah, that works. Yeah.
So do we only flip it twice because there's 2 possibilities? You can either get heads or tails and then flip it twice.
You can flip it more, but you're complicating it and it's unnecessary. Does that make sense? 4 flips was mentioned, but that's going to make a much more complex. You're going to have to list out a whole lot of stuff. Where 2 flips gets it done, actually. So, so this is a way of doing it. This is one way of saying it. You could also say in 2 flips not getting heads heads, right? What's another way of saying it? Any thoughts? Instead of saying not getting 2 tails, what could you say? How about if we said in 2 flips we get at least 1 head? Wouldn't that also work for 75%? It's not any better than saying it this way, it's just a different way. Or you could flip it around and say at least 1 is tails, right? So those are a couple of different ways. The last class, somebody in the last class said, well, how many different ways do we need to say it? 1. You don't want to repeat yourself over and over again, because what if one of your repeats is incorrect or poorly worded or something like that and somebody interprets it as incorrect? Say it once, say it clearly, and so this is just a couple different ways that it could be said, but you don't need to say it more than once. B. How can I use a standard die? I don't know that I like that one. It doesn't show up very well under there. Let's see if I can find a better die. It's smaller, but yeah, that's easier to see. So, how can I use a single die to come up with something that is going to show 75% probability of something happening. Can I do it with a single roll? So my probabilities for a single roll are 1 and 6, 2 and 6, 3 and 6, 4 and 6, 5 and 6, and 6 and 6. And in no case do we have quarters in that, right? So there's no way to get 75% with just a single roll. So what do we do with the coin? Yeah, Matthew. Okay, let's roll it twice, but let's write it out. So a die, 2 rolls. So I'm going to make a probability table for that. You don't have to make probability tables every time you do something, but certainly when you're trying to figure something out, it's pretty handy. So let's call this die 1. This would be die 2. Now wait a minute, Matthew said something about 12. Looks to me like there's more than 12 here. Yeah, can I split 36 into 4 equal parts? All right, yeah. So let's talk about how to mark this out. So there's a couple of things you could do. You could mark literally what you get, which is how I'm going to do this. Or in many games, you think of it as a total. So like, for instance, this would be 2, this would be 3, this would be 4. If you roll a 1 and a 3, it's 4. But I'm going to mark it like this. 1, 1. 1, 2, 1, 3. So now I have all the possible rolls that can be made with either 2 separate dice or 1 die being rolled twice. So how do I use that to come up with a 75%? This is where you have to get kind of creative. Anybody think of something? Yeah?
I just split it in odds and even numbers and decided 2 rolls get rid of those 2 even numbers.
So if you
I didn't write out all 6.
got 2 even numbers, you're saying that would be
So on my data table, I just did odds and evens,
ah,
just tails, but
I see.
less writing.
That's smart, because then you would have something just like this, right? Yeah, that's pretty smart. That totally works. If I saw that on a test, I'd be going like, smart girl, right? Okay, yeah.
You only need 4 numbers, so then you can just leave 2 out, and then if you say you just go like 3, 4, 5, 6, you leave 1, 2 out. If you get a 1 or a 2, you ignore it, and then if you get a 3, that's your one that's out, fail, and then the other 3 is your test. So it's 70%.
So if you get a 1 or a 2, you're out.
You just ignore 1 or 2, and then you roll again.
Oh, I see.
And then if you get a 3, that's your failure, and then 4, 5, and 6.
That, I'm sure that can be done. Okay, that can be done. But what if I say it has to be 2 rolls? I like the odds and evens. That's a slick way of thinking about it. But let's say this is what you've got. This one's a little tricky. The first class said something to the effect of you have to roll a 1, at least 1, 2, or 3. If you roll a 1, a 2, or a 3, that represents 75% of these rolls. Are they right? Yeah, because if they roll at least 1, 2, or 3, that works. That works. So it's probably not as elegant as the odd-even solution, but how about roll at least 1, 2, or 3. I'm going to say 1 here, O-N-E. How's that? That would do it. You could also use totals, come up with some creative thing. Here's something that I want you to see about this. This is actually a pretty handy deal at times. Get a pen that I know works. So this has a sum of 2, and this has a sum of 3. Okay, a pen that works, not that one. This has a sum of 3, and this has a sum of 4, and 4, and 4, and 5, and 5, and 5, and 5. What do you notice about the sums? They go diagonal if you aren't noticing. So like all the 7s, 7 is the most likely number that you can roll when you're rolling either a pair of dice or a die and then rolling it a second time. The whole numbers, or the sums, run in a diagonal. So another way you could do it is you could say, I don't roll a sum of 5 or a sum of 6. That would be a way to do it. Because there are 4 5s and 5 6s, and that's 9. That's 9. And 9 out of 36 is a fourth, right? So I don't roll. That would also work. Okay. All right, let's move on. Let's see, the next one is the random digits table. How could you use the random digits table to get a 75% probability in your next number choice? How would you arrange your numbers? Yeah.
Number 0, or it's like 1 to 100, and then 1 to 75, or 0, 1 to 75 is 75%.
Okay. Now I don't like your use of 100 though.
So there's 0, 0, 2.
Okay, so then if I use your first thing of 0, 1 to 77, So then it'd be, okay, or we could say 76 to 0, 0, right? Up through, and then, you know, kind of use the 0, 0 as your 100. You could do that. Yeah, I think it's more better if you say 0, 0 to 74, right? And 75 to 99, okay? I think I like that better, but I would understand this as well, okay? All right, so random digits table is pretty easy to set up, and then you just take 2 digits at a time, you know, or any 2 digits. D, how about a deck of cards?
Draw 4 cards. And have, yeah. We'll draw 4 cards and have one not be
Couldn't you draw 4 cards? And so the statement was draw 4 cards and have one not be a club. But isn't there a reasonable possibility that you would draw 4 cards and none of them be clubs? Or all of them be clubs? Oh yeah, I think, is that what you were? Well, you said. You said something that. Yeah. Yeah. So you could say, we pick hearts, spades, or diamonds, right? And pick any 3 suits. You said pick 4 cards.
It's not 4 cards, because you have 4 suits in a deck, so you just need to pick 3 out of 4 suits.
How about, instead of saying pick one of the 3, how about say pick a card that is not a suit, right? It is not a particular suit. I mean, you could state it that way as well. I'm going to pick, is that what you said? Okay. Pick a card that is not a heart. That would be a 75%. Now, I always run across students who've maybe never messed with cards in the past. So that's okay. If you haven't, a typical deck of cards has 52 cards, and there are 4 suits. I always think of them as like Lucky Charms, right? Hearts, diamonds, whatever. So the the suits are split into even amounts, 13 cards in each suit. Now, anybody